The efficiency score is up 40%.
The training data size is undisclosed.
I'm Milo.
I'm Mila.
This is AI Daily.
Later in the show, we'll be talking about why the U.S. Copyright Office just made life very complicated for AI artists.
But we're starting with Google, which just released a new family of small, open-source models that are punching well above their weight.
This morning, Google dropped Gemma 2, a new generation of its lightweight models. They come in two sizes, 9 billion and 27 billion parameters. For context, that's significantly smaller than most frontier models.
And that's the whole story here. These are designed to run efficiently on device. Think laptops and eventually phones. But the performance is the surprise. Google is reporting that the 27 billion parameter version is competitive with models more than twice its size, like Meta's Llama 370B.
Which brings us back to the numbers. The efficiency is impressive, but the technical report is light on details about the training data. It's a mix of web documents and code, but the scale and composition are not specified.
Right, and that's the core tension with open source models today. You get the weights, you can run the model yourself, but you don't necessarily get the recipe. The how is often as important as the what, especially when it comes to understanding biases or capabilities.
So the open question isn't just how good is it, but how did it get this good? For developers looking to build on this, that matters. It's the difference between using a tool and truly understanding it.
The immediate implication, though, is a big boost for on-device AI. More powerful small models mean more applications that can run without needing to call a cloud server, which is a win for privacy and speed.
And a challenge to companies that have bet heavily on device-first ecosystems. This is a direct shot across the bow. From tiny models to tiny building blocks of life, a new paper published this week demonstrates an AI system that can design novel proteins with specific functions from scratch.
This is a significant step. For years, the challenge has been not just predicting the shape a protein will fold into, but designing a new protein to do a specific job. Think of it as the difference between analyzing a blueprint and drawing a new one for a completely new type of building.
Researchers are using techniques inspired by image generation models, like diffusion. Instead of creating a picture of a cat from noise, the AI sculpts a cloud of atoms into a functional protein structure. The key breakthrough is that these aren't just theoretical designs. Some have been successfully synthesized and validated in the lab.
And the speed is the critical factor. Traditional methods for protein engineering can take years of trial and error. This AI-driven approach can generate promising candidates in seconds or minutes, radically accelerating the front end of the discovery process.
The primary application everyone talks about is drug discovery, creating proteins that can bind to a specific virus or a cancer cell. But the implications are much broader, from new enzymes for biofuels to self-repairing materials.
The paper notes this is still early. Lab validation is the essential and slow next step, but it shifts the bottleneck. Instead of spending years trying to come up with a design, scientists can spend their time testing a long list of promising AI-generated candidates.
It reframes the job of the scientist from architect to editor. The AI provides the drafts, and the human expert decides which ones to build.
And for our third story, the U.S. Copyright Office issued new guidance yesterday on AI-generated art, and it seems to have created more questions than answers.
The core issue has always been whether you can copyright something made by an AI. The Copyright Office has been consistent. No human authorship, no copyright. But this new guidance attempts to clarify the messy middle ground of AI-assisted work.
And it does so by introducing a concept of sufficient human control. It states that simply writing a detailed prompt, even a very creative one, is not enough to be considered the author of an AI-generated image. However, if a human creatively arranges or significantly modifies AI-generated material, that resulting work can be copyrighted.
Which sounds simple, but isn't. Where is the line between a detailed prompt and a significant modification? The guidance doesn't draw a clear one. It suggests a case-by-case analysis is needed.
I read the full document this morning. The logic has a recursive quality. It says the output isn't copyrightable if the AI determines the expressive elements, but the whole point of these models is that the human and the machine are shaping the expression together.
It creates a strange incentive. An artist might now be encouraged to heavily post-process an AI image in Photoshop, just across a fuzzy legal threshold, even if the original AI output was exactly what they wanted.
The guidance is a snapshot of the law trying to catch up to technology that is evolving weekly. The open question for every creator using these tools today is what sufficient control will mean tomorrow or next week.
Also in AI today,
a study out of UC Berkeley finds that since the broad adoption of AI chatbots, there's been a 30% increase in A grades in courses with take-home essays, but with no corresponding increase in measured learning outcomes.
OpenAI this week published research on an AI system that can autonomously discover and perform complex chemical reactions, moving from analyzing chemistry to actively doing it.
And finally, Google announced that the Gemini CLI, its command line interface for developers, will be sunset on June 18th, pushing users to migrate to its new agent platform, Anti-Gravity 2.0. So thousands of artists are now trying to figure out if their work involves enough human authorship.
A question for the lawyers, and eventually the courts.